So 1 0 1 0 1. Next, so what about subprime? So just check it out the subprime. Subprime, let me check that. So 4 digits, 111 0, right? Okay, so what we need to do with the subprime? Subprime ಏನು ಮಾಡಬೇಕು ನಾವು 2's complement ತಗೋಬೇಕು, right? Okay, so you make it a 1's complement first. 1's complement of this 0 0 0 1 and then plus 1 0 1 0 0, right?
Sir, minus and 1110 ಅಲ್ಲ ಸರ್?
1110
ಉಲ್ಟಾ ತಗೊಂಡಿದ್ದೀರಾ?
ಎಸ್ ನೋಡಿ, ಇದೆಲ್ಲ ಕನ್ಫ್ಯೂಷನ್ಸ್ ಆಗುತ್ತೆ, ಇದೆಲ್ಲ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಇದ್ರೆ ಆಯ್ತಾ. ಸೊ ಕರೆಕ್ಟ್ ಆಗಿ ಹೇಳೋದಿಲ್ಲ ಮೈಂಡ್ ಸೆಟ್. ಓಕೆ, ಸೊ my name is 14 1110. Yes, subtrahend is 10101. Okay, so right now subtrahend so must be 2's complemented. So before that, so you need to make it as a 1's complement. Okay, 01010 plus 1. Okay, so add this 1 0 1 0, right? So this becomes 2's complement. Okay, so what we need to do? Again you recomplement with 2's complement. 2's complement ತಿರ್ಗಾ ಮತ್ತೆ ಏನು ಮಾಡಬೇಕು, ಇದನ್ನ recomplement ಮಾಡಬೇಕು. Okay, recomplement this. So what happens? Recomplement ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ? So you consider this.
Sir, recomplement ಅಲ್ಲ, add.
Okay, so minus ಅಲ್ಲ, so first this 2's complement ಅಲ್ಲಿ ಇದೆ ಅಲ್ವಾ? Okay, so minus ಮೇಲೆ ಆದ ನಂತರ so ನಾವು ಏನು ಮಾಡಬೇಕು? Recomplement ಮಾಡಬೇಕು. Okay, so what is the minus? What is the minus? 1110. Okay, so the result should be recomplemented again. Okay, so 1 1 0 1 0. Okay, so add with the minus. Okay, 1 0 1. 1 plus 1 is 0, 0 plus 0 is 1 is carried. 1 plus 1 is 0, 1 will be carried, and then so 0 plus 1 is 1. And then so 1 plus 0 is 1 as it is. Okay, once again you make a 2 complement of this. Okay, so first the 1's complement ಮಾಡೋಣ. 0 0 1 1 0 plus 1 1 1 1 0 0. Check ಮಾಡಿ, ಸರಿ ಇದೆಯಾ? 0 0 1 1 1 2 4 0 4 1 2 4 2. So 4 plus 2 plus 1, there will be a 7, and then add the negative sign in front of that. Okay, so it is 0 0 ne barutte, so just you consider 3 digits. Okay, 4 plus 2 plus 1 is 7, so put negative sign here. Okay, otherwise you can 8 digit alli ಮಾಡಬಹುದಾ? 7 ಇದೆ ಅಲ್ವಾ, 8 digits alli 8 bit alli ನೀವು sign and magnitude method ನಲ್ಲಿ represent ಮಾಡಬಹುದಾ? Can we represent this -7 in sign and magnitude method 8 bits ಮಾಡಬಹುದಾ? Can we do this negative number? Can we represent this negative number in sign and magnitude method? Can we represent ಮಾಡಬಹುದಾ? 8 bits ಅಲ್ಲಿ represent ಮಾಡಬಹುದಾ -7 ನ? Yes or no? 8 bits ಇದೆ ಅಲ್ವಾ, 8 bits within 8 bits ಇರುತ್ತಲ್ವಾ, 7 ನೋಡಿ ಚೆಕ್ ಮಾಡಿ, ಮಾಡಬಹುದಾ?
Yes sir.
Can we represent using sign and magnitude method? ಮಾಡಬಹುದಾ?
Yes sir.
Can we do? But the thing is, so you need to represent with 1 ಅಷ್ಟೇ.
ಸರ್ ಕೆಳಗಡೆ ಕಾಣಿಸ್ತಿಲ್ಲ.
What?
ಕೆಳಗಡೆ ಕಾಣಿಸ್ತಿಲ್ಲ ಸರ್. Board is not visible down sir.
Okay, is it okay now? ಈಗ ಕಾಣಿಸ್ತಾ ಇದೆಯಾ?
No sir. Yes sir, now it's visible.
ಸಾಕಷ್ಟೇ ಬೋರ್ಡ್, ಇದನ್ನೇ ಚೇಂಜ್ ಮಾಡಲ್ಲ ನಾನು ಈಗ. ಸೊ ಅದ್ರ ಒಳಗಡೆ ಬಿಟ್ವೀನ್ ಅಡ್ಡಾಡ್ತಾನೆ ಬರ್ತೀನಿ. ಸೊ ಇದಾಯ್ತಾ ಪ್ರಾಬ್ಲಮ್ ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಹೇಳಿ. ಹೇಳಿ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಹೇಳಿ ಮಾಡೋಣ.
ಸರ್ ಇವಾಗ 2 - 1 ಮಾಡಕ್ಕಾಗತ್ತೆ ಸರ್, ಬಿಕಾಸ್ 1 ಅಂತಾನೆ ತಗೋಬೇಕಲ್ವಾ?
1 - 2 ಮಾಡಬೇಕು. 2 - 1 ಮಾಡಕ್ಕಾಗಲ್ಲ, ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ
ಅದೇ 1 - 2
ಸಬ್ಟ್ರಾಕ್ಟ್ ಅಲ್ವಾ, ಅದು ಮಾಡ್ಬೋದು. 1 - 2, so it becomes -1 ಮಾಡ್ಬೋದು. ರೈಟ್. ಸೊ ಫಸ್ಟ್ 1 ಅನ್ನು ಡಿವೈಡ್ ಮಾಡಿ. ಏನಂತ ಬರ್ಕೋತೀರಾ? 1 ಅಂತ ಅಂದ್ರೆ 2 ಪವರ್
ಸರ್ ಅದಕ್ಕೆ 2 ಪವರ್ 0
ಅಷ್ಟೇ 1 ಅಂತ ಬರ್ಕೋಬೇಕು. ಅದಾದ್ಮೇಲೆ ಇದನ್ನ 2 ಪವರ್ 0 and 2 ಪವರ್ 2 ಪವರ್ 1. This is 2 ಪವರ್ 0, this is 2 ಪವರ್ 1.
ಎಸ್ ಸರ್.
ಮಾಡ್ಬೋದು. ಬೇರೆ
ಸರ್ ಅದು ಸಾಲ್ವ್ ಮಾಡಿ ಒಂದ್ಸಲ.
ಇದಾ? ರೈಟ್. ಸೊ ಏನಂತ ಬರ್ಕೋತೀರಾ ಫಸ್ಟ್? -8. Okay, so -9 should be written just like 1 and then subtract. Subtract ಏನಂತ ಬರ್ಕೋಬೇಕು ಅಂತಂದ್ರೆ 1 0 ಅಂತ ಬರ್ಕೊಳ್ಳಿ. You make this as 1 0. Okay? Okay na? Next. So subtract ಇರುತ್ತಲ್ಲ, subtract you make it as in 1's complement first. 1's complement ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ? 0 1. Okay, so 1's complement ಆಯ್ತು. Next plus 1. 1 plus 1 is 0, so 1 will be carried. So 1 0 ಆಗುತ್ತೆ. ತಿರ್ಗಾ ಮತ್ತೆ. Okay na? So ಇದು 2's complement. 2's complement ಆಯ್ತು. ಸೊ ಈಗ ಆಡ್ ಮಾಡಿ. ಸೊ 1 ಜೊತೆ 1 1 0. 1 plus 0 is 1. 1 you keep as it is. Okay. Next, so this is should be recomplemented. 1 1 ಅಂತ ತಗೊಳ್ಳಿ. Okay. So 1's complement ಮಾಡಿ. 1's complement ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ? What should be that? 0 0. So plus 1 ಮಾಡಿ. 0 plus 1 is 1. Next, so 0. 2 power 0 is 1. So 1 will be the answer. Okay, so you keep 1 in front of this. That's it. Okay, 0 1 ಬರುತ್ತೆ. ಅದರ ಮುಂದೆ ನೀವು ಏನು ಮಾಡಬೇಕಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ಮೈನಸ್ ಸೈನ್ ಹಾಕಬೇಕು. ಓಕೆ, ಸೊ 0 1. 2 power 0, 2 power 1. 2 power 0 is 1. 1 ಆನ್ಸರ್ ಬರುತ್ತೆ. ಸೊ ಇದು 0 ನೇ. 2 power 1 is 2. 2 into 2 0 ಅಂತಂದ್ರೆ 0 ಬರುತ್ತೆ. 1 you are getting an answer. Okay, keep the sign negative here. That's it.
-01 ಬರೆಯಂಗಿಲ್ವಾ ಸರ್? -1 ಮಾತ್ರ ಬರೀಬೇಕಾ?
ಯಾವ್ದನ್ನ? ಇದಾ?
ಟೋಟಲ್ ಆನ್ಸರ್
ಇಲ್ಲ ಇಲ್ಲ, -01 ಅಂತಾನೆ ಬರೀರಿ. ಹೀಗೇನೆ ಬರೀರಿ. ಹೀಗಲ್ಲ, ಇಷ್ಟನೇ ಆಯ್ತಾ? ನಾವು ಇಲ್ಲಿ ವೆರಿಫಿಕೇಶನ್ ಅಲ್ಲಿ ನಾನು ಇದು -1 ಅಂತ ಬರೀತೀವಿ. ಇಷ್ಟು ಬರೋದು ಸಾಕು. ನೆಗೆಟಿವ್ ಸೈನ್ ಹಾಕಿ ಇದನ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿ, ಯಾಕಂದ್ರೆ ಗೊತ್ತಾಗ್ಬೇಕು ತಾನೆ. ಇಲ್ಲಿ ಆಡ್ ಮಾಡಿರೋದು ಗೊತ್ತಾಗ್ಬೇಕು, 2's ಕಾಂಪ್ಲಿಮೆಂಟ್ ಮಾಡೋದು ಗೊತ್ತಾಗ್ಬೇಕು, ತಿರ್ಗಾ ಮತ್ತೆ ಇಲ್ಲಿ ರೀಕಾಂಪ್ಲಿಮೆಂಟ್ ಮಾಡೋದು ಗೊತ್ತಾಗ್ಬೇಕು. 01 ಅಂತಾನೆ ಬರೀರಿ. ಓಕೆ, ಸೊ 01 ಅಂತ ಅಂದ್ರೆ ಸೊ ಇಟ್ ಇಂಡಿಕೇಟ್ಸ್ ದಟ್ -1 ಅಂತ ಇಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡಿದ್ವಲ್ಲ. ಓಕೆನಾ ನಿಂಪಣ? ಕ್ಲಿಯರ್ ಅಲ್ಲ?
ಓಕೆ
ಸರ್. ಡೌಟ್ ಇದೆಯಾ ಇದರಲ್ಲಿ? ಎನಿ ಡೌಟ್ಸ್ ಇನ್ ದಿಸ್? Right, so tell me some more numbers. Okay, so we'll solve and then we'll go with the computer course afterwards. Any number again? Kusuma, here number 8. Minus should be smaller than the subtrahend. So here next to solve our better. Okay. Kusuma. Hey, number 8. Sai Charan. Number 11. Minus is smaller than the subtrahend. Minus smaller than the subtrahend. Srinidhi, ನೀವು ಹೇಳಿ. Minus should be smaller than the subtrahend. Srinidhi, number, any number, 2 digit, 3 digit number.
101.
101 minus, this should be a bigger number.
101. 110.
110 minus 9, right? 101 divided by 2. Okay, so 50, remainder 1. Next 25, remainder 0. Next 2 12 are remainder 1. Next 2 6 are remainder 0. Next 2 3 are remainder 1. 2 1s are remainder 1. Okay, so this is LSP, this is LSP. Okay, so then what about this 110?
So 2 3s are 0 remainder.
6 are. 2 1s are 2, remainder is 1. Okay, so 55, remainder 0. 2, so 27 are remainder 1. 2 13 are remainder 1. Next 2 6 are remainder 1. Next 2 3 are remainder 0. Next 2 1s are remainder 1. Okay, this is LSD, this is MSD. Okay. Okay, so minus end is 1 1 0 0 1 0 1 1 1 1 double 0 1 0 double 1. Hey, sorry, 1 1 1 0 0 1 0 1. Next, so what about this 1 1 0 1 1 1 0. 2 3 4 5 6 7 1 2 3 4 5 6 7 8 2 4 3 correct ಆಗಿದೆ ಇದು 3 7 ಓಕೆ ನೋಡಿ ಇದು ಕರೆಕ್ಟ್ ಆಗಿದೆ ಮೈನಸ್ ಅಂಡ್ ಸಬ್ಟ್ರಾಕ್ಟ್ ಕರೆಕ್ಟ್ ಆಗಿದೆ ನೋಡಿ. Okay, so we make it 1's complement first. 0 1 0 0 0 1 plus 1, add with this 0 1 0 0 1 0 0. Okay, so and then so you add with this 1 1 0 1 and 1 0 1. So 0 0 1 0 0 1 0. Okay, sorry. 1 1 1 0 1 1 1. Okay, so you take the 1's complement of this again. So 1's complement, say 0 0 0 1 0 0 0 plus 1. 1 0 0 1 0 0 0. Okay, you consider the ultimate result 0 0 0 1 0 0 1 2 4 0 2 4 1 2 4 2 2 4 3 2 4 4 2 4 5 2 4 6. Okay, 2 4 3 is 8 8 plus 1 is 9. Okay, so add the negative sign here, and then you put the negative sign in front of this. Is that clear? ಸರಿ ಇದೆಯಾ? ಚೆಕ್ ಮಾಡಿ. ಸಾಯಿ ಶರಣ್, ಶ್ರೀನಿಧಿ ಕರೆಕ್ಟ್ ಆಗಿದೆಯಾ ನೋಡ್ರಿ. ಆನ್ಸರ್ ಕರೆಕ್ಟ್ ಆಗಿದೆಯಾ? ಶ್ರೀನಿಧಿ ಯಾರು
ಸರ್ ಮೇಲ್ಗಡೆ ಬರ್ತಿರೋದು ಕಾಣಿಸ್ತಿಲ್ಲ. ಎಸ್ ಸರ್ ಕಾಣಿಸ್ತಿಲ್ಲ. 1 second.
Okay, so downwards also is visible to everyone. ಎಲ್ರಿಗೂ ಕಾಣ್ತಾ ಇದೆಯಾ?
If it's visible up, it's not visible down. If it is visible down, it's not visible up.
Now it is visible. Entire screen. So correct ಆಗಿ ಚೆಕ್ ಮಾಡಿದ್ದೀನಿ. ಪೂರ್ತಿ ಸ್ಕ್ರೀನ್ ಕರೆಕ್ಟ್ ಆಗಿ ವಿಸಿಬಿಲಿಟಿ ಇದೆಯಾ ನೋಡಿ ಈಗ.
ಸರ್ ಮೇಲೆ ಮೈನ್ಯೂ ಅಂಡ್ ಸ್ವಲ್ಪ ಕಟ್ ಆಗಿದೆ, ಬಟ್ ಸಾಲ್ವ್ ಮಾಡಿದೀವಲ್ವಾ ಸರ್ ಗೊತ್ತಾಗುತ್ತೆ.
Okay. Shall we go with the computer codes? Sakalva. Next computer codes ಹೋಗೋಣ. Binary coded decimal. Okay. Yes. Right. Okay. So ಆಯ್ತಾ ಇದು finished? Any doubts in this subtraction from 2's complement? Okay. Both minor end is smaller and then subtrahend is smaller. Both minor end is bigger and then subtrahend is bigger. ಎರಡು cases, case 1 case 2 ಎರಡು solve ಮಾಡಿದೀವಿ. Okay, smaller number to bigger number to smaller number, both we are subtracted. Okay, binary subtraction, that too 1's complement subtraction and 2's complement subtraction. So case number 1, case number 2 in 1's complement, case number 1 and case number 2 in 2's complement. Is that clear everyone? ಅರ್ಥ ಆಯ್ತಾ? ಇನ್ನೊಂದ್ಸರಿ ಹೇಳ್ಬೇಕಾಯ್ತು. So ಮುಗಿಸೋಣ. So computer codes ಹೋಗೋಣ. The last concept in this chapter is computer codes. Yes. Okay, so the next thing is computer codes. So as we know, the computer doesn't understand our language. What does it understand? What does the computer understands? In which language the computers understand, interprets and gives the results? The computer always understands in the terms of zeros and ones. That is what we call the binary language. Binary language is also called as machine level language. In other words, the machine level language is also called as low level language. Okay, so we can refer the computer language as machine level language, low level language or binary language. It's always accepts, interprets and gives the output, so in the form of zeros and ones. So the data, any data, so we will input. Okay, the computer codes helps us in representation of data. In computer. Representation of data in computer. Okay, so computer always understands only binary language. binary languages. So binary languages are nothing but in the terms of zeros and ones. We have certain codes to represent the computer codes. Okay, so that is what we call computer codes, representation of the data. Okay, so through the user to the computer. Okay, so that representation of data that is accepted by the computer, interpreted by the computer, and gives the output to the user. Okay, according to the user readable format. That codes will be called as a computer codes. Okay. Okay, the better method is binary coding. Okay. The computer code represents various characters, numbers, and special symbols. Right? The computer codes represents various characters, numbers, and special symbols. Okay? You can say it as a digits. Okay? The computer codes represent various characters, digits, and special symbols.
Sir,
Characters are alphabet, right? So 11. So character can be or uppercase, lowercase. So capital letter, small letter we will call usually in English. Okay, so in computer science we will call a capital letter as uppercase and then so small letter as a lowercase. Okay, and the digits are from 0 to 9. And then special symbols are hash, at, colon, semicolon, question mark, comma, full stop, etc. Okay, so around 30 special symbols we will have. Okay, so this is we can represent to the computer code as a computer code. So usually, so computer always understands binary language. Okay. Okay, some of the commonly used computer codes are okay, so first one is BCD, binary coded decimal. Binary coded decimal. Next. XS3. Okay, so XS3 also called as XS3. XS3. Next is EBCDIC. EBCDIC, extended binary coded decimal interchange code. Okay, extended binary coded decimal interchange code. So one more is that is ASCII. So I'll write here ASCII, American Standard Code for Information Interchange. American Standard Code for Information Interchange. So these are the commonly used computer codes. Okay, so BCD, binary coded decimal. Next XS3. Next extended binary coded decimal interchange code. Okay, so the one more
Sir.
is ASCII.
It's not visible, sir, down. No, sir.
Is it
No.
okay?
No, sir.
Now?
Sir, little up. No, sir. No, sir. Little. Yes, sir. It's visible, but last two words. Yes, sir. Now it's visible, sir.
Okay, American Standard Code for Information Interchange. Okay, so BCD, binary coded decimal, XS3 or XS3, EPDIC, extended binary coded decimal interchange code. Next, this is ASCII, ASC, American Standard Code for Information Interchange. Okay, these are the 4 commonly used computer codes. Okay, computer code helps us in representation of the data in computer. The computer always understands in the terms of binary language, that is zeros and ones. Any data can be represented either using zeros and ones. The computer codes represent various characters. Characters is uppercase and lowercase, and the digits are 0 to 9, and then special symbols are, so as we know, so this will be available on the keyboard. Okay, some of the commonly used computer codes are BCD, binary coded decimal. Next, XS3, then EBCDIC, EBCDIC, extended binary coded decimal interchange code, and then it is ASCII. The finally it is ASCII, American Standard Code for Information Interchange. Okay, is that clear, everyone? Is that clear? So whatever may be the data can be represented so in the computer, that is through the computer codes. Okay, so here is the represent either character, digits or special symbols. Okay, we have 4 computer codes. Okay, so BCD, binary coded decimal. Next, XS3 or XS3. Next, EPDIC, extended binary coded decimal interchange code. Then it is an ASCII, American Standard Code for Information Interchange. Okay, so first we take binary coded decimal BCD. Okay, is that clear, everyone? ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಆಯ್ತಾ ಇದು ಅಳಿಸ್ಬೋದಾ? Shall I erase this?
Yes, sir.
Okay, so first one, binary coded decimal BCD. Binary coded decimal. Binary coded decimal. Okay, so it is also one of the computer codes. Okay, so it is one of the computer codes. Okay, and then this coding system follows left to right positional weight. Okay, it is 8, 4, 2, 1. Okay, so what do you mean by this left to right positional weight? ನೆನಪಿದ್ಯಾ ಇದು ಏನಂತ ಬೈನರಿ ನಲ್ಲಿ?
ಸರ್ 2 power 0, 2 power 1, 2 power 2, 2 power 3.
2 power 1 ಇದನ್ನ ರೌಂಡ್ ಅಪ್ ಮಾಡಿ ಬರ್ತಿದ್ದೀನಿ. This is 2 power 2. This is 2 power 3. Okay, so 8, 4, 2, 1. Okay, this is the positional weight. So which is having the left to right positional weight. Okay, so ಈ ರೀತಿನೇ ಬರಿಬೇಕು 8, 4, 3, 2, 1 ಅಂತ ನಿಮಗೆ ಗೊತ್ತಾಗಲಿ ಅಂತ ಹೇಳಿ ನಾನು ಈ ರೀತಿ ಬರ್ತಿದ್ದೀನಿ. Binary coded decimal. Okay, yes. Okay, this is the binary number and this is its equivalent decimal number. ಹೌದಾ? ಇದು decimal number ತಾನೆ. 2 power 0 ಅಂತಂದ್ರೆ it's a 1. Next 2 power 1 ಅಂದ್ರೆ 2. So 2 power 2 is 4. Next 2 power 3 is 8. Okay, like this. Right? Next, since these weights are place value in the binary system. Place value in the binary system. A decimal digit is encoded and its binary representation. Binary representation. Okay, since these weights are place value. Okay, this is place value is 8, 4, 2, 1. Okay, so ಇದು ಆದ್ಮೇಲೆ 16, 32, 64, 128 ಈ ರೀತಿ ಬರುತ್ತೆ. Okay, so just now ಇದನ್ನ ಏನು ಬರೀತೀವಿ. So the place value will be considered and this will be encoded and it's the binary representation. Okay, so tell me any number. ಯಾವ್ದಾರ ನಂಬರ್ ನ ಹೇಳಿ ಈಗ. Any number. So ಅದನ್ನ ನಾವು 8, 4, 2, 1 positional weight ನಲ್ಲಿ ಬರೆಯೋಣ. Example. Consider any example. So I'll write 4 bits. 4 bits that includes ನೋಡಿ. So 4 bits ಅಂತಂದ್ರೆ 2 to the power of 4 it is 16. Okay. So ಈ ರೀತಿ represent ಮಾಡೋಣ. Tell me any number. Decimal number ಯಾವ್ದಾದ್ರು example ಹೇಳಿ. Any example that can be encoded in binary format. Binary coded decimal ಆಗಿ ನಾವು ಬರೀಬಹುದು ಅದನ್ನ. Any number. Okay, that should be in the format of 8, 4, 2, 1. ಹೇಳಿ ಯಾವ್ದಾದ್ರು number 3 digit 4 digit number ಹೇಳಿ. Any number. Decimal number ಹೇಳಿ ಅಷ್ಟೇ. 2, 3, 1. Yes. 2, 3, 1. ಈಗ ನೋಡಿ. So 2, 3, 1 ನ ಇಲ್ಲಿ 4 digits ಅಲ್ಲಿ ಬರಿಬೇಕು ಅಂತಂದ್ರೆ ಹೇಗೆ ಬರೀತೀವಿ? 1. ಹೌದಾ? Yes.
Yes, sir.
Okay, so ಈಗ ಇದನ್ನ ಹೇಗೆ ಬರೀತೀವಿ? So this will be written like this. Okay, so how the 3 will be written? 3 ನ ಹೇಗೆ ಬರೀತೀರಾ? 1, 1, 0, 0. ಸರಿನಾ? 3 will be written like this. ಹೌದಾ? 2 power 0 is 1. 2 power 1 is 2. 2 plus 1 is 3. Correct? Are you getting my point? ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಕಂಪ್ಯೂಟರ್ ಕೋಡ್ಸ್ ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಬೈನರಿ ಕೋಡೆಡ್ ಡೆಸಿಮಲ್ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? Is that clear everyone? 4 digit ನಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. Okay, so 2 power 4 is 16. Okay, so 4 digit ನಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂತಂದ್ರೆ so this is how we write this in 4 digits.
0010.
ಅಲ್ಲಿ ಹೇಗೆ ಬರೀತೀರಾ? 0 0 1 0. ಕರೆಕ್ಟಾ? Is that clear? This is what we call binary coded decimal. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಬೈನರಿ ಕೋಡೆಡ್ ಡೆಸಿಮಲ್ ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? Is that clear everyone? Is that clear? So it is one of the computer codes. This coding system follows the left to right original weights. So that is 8 4 2 1. 8 4 2 1 2 power 3 2 power 2 2 power 1 2 power 0. So since these weights are place value in this binary number system, a decimal digit can be encoded and its binary representation. Is that clear? And we will represent here. So we'll with the 4 bits, nothing but 2 to the power of 4, that is 16. It becomes okay. Totally ಇಷ್ಟು ನಾವು ಎಷ್ಟಕ್ಕೆ represent ಮಾಡಿದೀವಿ ಅಂತಂದ್ರೆ so 4 digits ಮೇಲೆ represent ಮಾಡಿದೀವಿ. Okay na? 2 3 1 can be written in the 4 digits like this. Okay? Is that clear everyone? ಅರ್ಥ ಆಯ್ತಾ? Is that clear everyone? ಕಂಪ್ಯೂಟರ್ ಕೋಡ್ಸ್ ಕಾಣ್ತಾ ಇದೆ ಅಲ್ವಾ ಇದು? ಸೊ ಈ ಬೋರ್ಡ್ ಮೇಲೆ ಬರ್ದಿರೋದು ಕಾಣ್ತಾ ಇದೆ ಈಗ? ಕ್ಲಿಯರ್ ಕಾಣ್ತಾ ಇದೆ ಎಲ್ಲರಿಗೂ?
ಸರ್ ಇದು ಹೆಕ್ಸಾಡೆಸಿಮಲ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಹಿಂಗೆ ಅಲ್ವಾ ಮಾಡೋದು?
ಹಾಗೆ ಮಾಡೋದು. ಸೊ BCD ನ ನಾವು ಹೀಗೆ ಬರೀತೀವಿ, ಆಲ್ರೆಡಿ ನೀವು ಬರ್ದಿದ್ದೀರಾ ಅದನ್ನ. ಓಕೆ, ಇನ್ನೊಂದು ಸೊ ಇದನ್ನ ಝೋನಲ್ ಬಿಟ್ ಅಂತ ಕರಿತೀವಿ. ಆ ಝೋನಲ್ ಬಿಟ್ ನ ಎಕ್ಸ್ಟ್ರಾ ಬರಿತೀವಿ ಅಷ್ಟೇ. ಇದರಲ್ಲಿ 2 ಝೋನಲ್ ಬಿಟ್ ಬರೀತೀವಿ, ಆಯ್ತಾ? ಎಕ್ಸ್ಟೆಂಡೆಡ್ ಬೈನರಿ ಕೋಡೆಡ್ ಡೆಸಿಮಲ್ ನಲ್ಲಿ, ಇಂಟರ್ಚೇಂಜ್ ನಲ್ಲಿ. ಸೊ ಅದರಲ್ಲಿ 4 ಝೋನಲ್ ಬಿಟ್ ಬರೀತೀವಿ. ಇದರಲ್ಲಿ 2 ಝೋನಲ್ ಬಿಟ್ ಅಂತ ಬರುತ್ತೆ ಎಕ್ಸ್ಟ್ರಾ, ಅದನ್ನ ಅಡಿಷನ್ ಮಾಡಿ ಈ 4 ಬಿಟ್ಸ್ ನ ಬರೀತೀವಿ. ಓಕೆ, ಅದಕ್ಕೆ ಬೈನರಿ ಕೋಡೆಡ್ ಡೆಸಿಮಲ್ ಅಂತ ಕರಿತೀವಿ. ಇದು ಅರ್ಥ ಆಯ್ತಾ? ಇಷ್ಟು ಅರ್ಥ ಆಯ್ತಾ? ಇವತ್ತು ನಾಳೆ ಚಾರ್ಟ್ ನ ಬರ್ಸ್ತೀನಿ. ಓಕೆ, ಇಷ್ಟು ಅರ್ಥ ಆಯ್ತಾ ಎವ್ರಿವನ್? ಎನಿ ಡೌಟ್ಸ್ ಇನ್ ದ ಸೆಷನ್? ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ ಈ ಸೆಷನ್ ಅಲ್ಲಿ? ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ? ಎನಿ ಡೌಟ್ಸ್ ಇನ್ ದ ಸೆಷನ್?
No doubts.
ಐ ಆಮ್ ಆಸ್ಕಿಂಗ್ ಎವ್ರಿವನ್.
No, sir.
ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಇಷ್ಟು ಮಾಡಿದ್ದು ಇವತ್ತು ಮಾಡಿದ್ದು ಅರ್ಥ ಆಯ್ತಾ? ಸಬ್ಟ್ರಾಕ್ಷನ್ ಫ್ರಮ್ 2's ಕಾಂಪ್ಲಿಮೆಂಟ್, ಮೈನ್ಯೂಟ್ is smaller than subtrahend. ಅದಾದ್ಮೇಲೆ ಸೊ ಕಂಪ್ಯೂಟರ್ ಕೋಡ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಎನ್ಕೋಡೆಡ್. ಓಕೆ, ಸೊ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ದ ಲಾಂಗ್ವೇಜ್, ಸೊ ವಾಟ್ ವಿ ಯೂಸ್, ಸೊ ವಿ ಕ್ಯಾನ್ ಎನ್ಕೋಡ್ ದ ಎನಿ ಕ್ಯಾರೆಕ್ಟರ್ಸ್, ನಂಬರ್ಸ್, ಸ್ಪೆಷಲ್ symbols through the computer codes. And we have 4 computer codes: BCD, binary coded decimal, and then XS3. Okay, XS3. And then so EBCDIC, extended binary coded decimal interchange code. Next, so ASCII, American Standard Code for Information Interchange. So in that, so binary coded decimal can be represented like this. Okay, is that clear everyone? Is that clear everyone? So this is also
Yes, sir.
is also used to represent the data in the computer. Okay, is that clear everyone? Artha aita? Any doubts in this session? Eno doubt illa tane? Yana doubt idya?
No doubts, sir.
Okay, so tomorrow I'll continue with the chart. Okay, so you'll write the chart. Okay, so on the binary coded decimal. Okay, so and I will continue the next concept, that is XS3, and then so EBCDIC we have, and then finally ASCII. Okay, bye everyone.